So I want to warn everyone up front that I did training and I've been talking like nonstop, so my voice is kind of hoarse, so I'm going to try to be very understandable. But if it's scratchy, I apologize. So goals here, and again, it sounds dry, but hopefully it'll be good, is understanding basic tenets of security. So things just went back, didn't they? I don't think I touched anything. Understanding basic tenets of security. So these are things like how we, the Vault team, think about security, what it means, what the various principles are, the properties necessary for secret management and initial secret distribution, and applied security in action. So I'm going to be talking at a more general level, showing how we build up security principles in Vault that we can leverage into good workflows, secure workflows. So it's going to talk about secure introduction and response wrapping and orchestrators, but this is not a Nomad and Vault talk. And pretty explicitly, I'm going to talk about the fact that this is something that we worked on very agnostic to what's going to implement it. It's not a discussion of crypto theory. There are probably people in this room that know more crypto theory than I do. And when you're talking about applied security, crypto properties are usually what you really care about. You know, which algorithms should you use, what's appropriate for your current task, things like that. So we can stay pretty high level. It's not going to be a comparison of container, hypervisor, OS security, et cetera. I'm going to talk about containers a bit, but we'll just talk about Docker. We'll talk about Linux. Not a deep dive into security rabbit holes. We're going to keep paranoia to a pretty low level, keep it in check. It's really easy in the security community to be like, okay, you're doing that, but like, what if someone does a side channel timing attack against your cache lines? And you're like, okay, but can we just keep people off my CPU, please, maybe? Like, let's focus on that and just minimize that. So, starting out at a very basic level, what is security? Security is a practice of risk management. Deciding which risks can be accepted and which can't, and guarding against violations of norms. So, norms are things like strangers should not get access to your database. We can probably all agree on that. That's a norm. A non-employee should not be able to send email from your domain, right? Probably shouldn't be able to do that. This applies to the non-tech world. So if you're talking about personal security, right, bodyguards, personal security is practicing risk management. You are minimizing the risk that somebody is going to punch you in the face, right? So personal security, locking your doors, things like that, that's risk management as well. InfoSec departments often own the risk management, incident management process for this reason. So when you think about like outages that happen, that's often something that's triaged and driven by InfoSec. So risk increases with system complexity. There's probably nothing surprising there. More points of failure, confusion, ingress, egress, more ways your data could get in and out, more things that can go wrong. Threat. Anything that elevates risk is a threat, right? So modeling threats informs security policy. So if you look at the world around you and you say like, all right, how might somebody try to screw with me, right? That's you modeling security policy. It might be your personal security policy, but that's essentially you doing the same exact thing that you need to do in your business. So it's a secret. A secret is something that elevates your risk if exposed. So this causes things that are harm. Undesired consequences. This could be unauthorized data access, it could be financial loss, regulatory fines, it could be even something as kind of vague as the fact that customers may not trust you anymore. So the next time they want to buy a new device, they may go to someone else. Those are all harm. Exposure. So now kind of wrapping this all together, an exposed secret elevates risk, may cause harm, so it's a threat. Exposed secrets are threats to your organization. And not everything that you might want to keep kind of sensitive or private is necessarily a secret. So some things that could be disclosed are basically identifiers, and we sort of like minimize. We kind of say, you know what, we're just going to accept the risk that goes away. So usernames are usually identifiers, they're not secret. Passwords are secret. Your TLS cert is out there for anyone to see. It has your public key in it, but your private key that's associated with that public key, that's secret. Identifiers aren't completely risk-free. It's information that someone can try to use to get access to the private parts, the secret parts of whatever that's associated with. But we've chosen to ignore that risk because otherwise it's just more things you have to deal with. It expands the problem space quite a lot. Trust. So a trusted entity is one that will not divulge the secrets that it has access to. So if you tell me something, you say it's a secret, and I tell you I will not tell that to anybody until the day I die or even beyond, that is, you can trust me. I am a trusted entity in that respect. Modeling trusted entities is the companion to modeling threats. So when you're talking about modeling what people can do to mess with you and cause you harm, then you also have to basically model who can I trust along the way. So there's two concepts here. The first concept is a circle of trust. These are entities that we can trust with any secret. So for this talk, we're going to put CPU in your circle of trust, your RAM in your circle of trust. A secret management tool necessarily probably belongs in your circle of trust. Employees may or may not. Maybe you trust your employees, maybe you don't. Maybe you trust certain employees. Root access. Usually if someone has root access, they get access to anything anyways, so you pretty much have to have it in your circle of trust. And you want to prevent people from getting it. Cloud. I have been told by people that know what they're talking about that AWS and Google have really good management around who can access what in AWS and Google Cloud Platform and when they can get access and what oversight there is and so on. So maybe you trust your cloud provider. Things that are not in the circle of trust are things like persistent storage, if it's not encrypted. Your mother's notepad.txt where she puts all of her passwords and still does it, that is not not in your circle of trust. The NSA, probably not in your circle of trust, right? The only allowed long-term storage is in your circle of trust. If you have secrets moving around, it needs to be in your circle of trust or you cannot trust it. It will be divulged, it will be exposed. Now, what is in your circle of trust is going to depend on you and your organization and your risk management and what you choose to trust. So the next concept is a chain of trust. These are the set of links, like network hops is usually the case, that any particular secret travels through from source A to destination B. Both ends of this must be in the circle of trust, because by definition, we're basically saying there is a secret, so therefore the long-term use or storage of the secret has to be in our circle of trust, so that has to be the source and destination of the chain. Any link in a chain of trust is a potential access point or interception point. So these are things like accidental logging, right? That's not malicious, but it'll still expose secrets, and that's a threat. Exploitation by attacker, lookup by operator, employee post-it note with the password just sitting on the monitor, that's a problem. Conspiracy of one, so compromised employee, owes debt, needs to make some money, whatever. Okay, so now that we've discussed all those concepts, and we've discussed circles of trust and chains of trust, we can establish a problem space. So managing secrets in an environment, in your environment, means establishing trust chains in your environment. Means figuring out how you can securely get secrets from point A to point B. Links in the chains have associated risk. We try to minimize hops and minimize risk per hop. So in other words, figuring out how to securely get a secret from the producer to the consumer, and you're about to say, duh, I already knew that, why am I here? Because it's kind of intuitive, but you have to take the roundabout approach because we have to understand things like a circle of trust, a chain of trust, because that's very important to know. And only after we understand that can we actually get to a point where we can figure out how to minimize that risk in our organization. Risk cannot be fully mitigated, ever. You must assume that any given secret will eventually be divulged, right? So maybe that's 100 years' time, maybe it's 5 seconds. You don't know, but you basically have to just make that assumption that secrets will get out. The ultimate goal is zero trust. Don't give opportunity for risks to occur in the first place, right? So if you have persistent storage that's encrypted, don't give the access key out to everybody. Don't give the encryption key out to all of your employees. Minimize that risk. Ultimate goal is zero trust. Always keep that in mind. 1 second. All right. So let's say that we have a scheduler, a container, a scheduler agent, a secret management tool. A secret management tool, it's hard to see on here, but it's actually kind of grayed out because that's sort of, not yet in our example. And I'm going to go back to this diagram a few times. So the goal is securely move secret from originator, the source in our chain of trust, to new containers RAM, the destination in our chain of trust. What does it look like? Does it look like this? Does it look like that? Does it look like this? Sometimes I press this and it just doesn't do anything. All right. So we need to figure this out, right? This is the problem space. We need to figure out how to get from point A to point B. So we're going to talk about security properties and success criteria. All right. So establishing a chain of trust requires defining the requirements that must be fulfilled to keep that secret protected. So the good news here is, that's kind of an abstract notion, but the good news is we often only need to do this for one secret. So the first secret can authenticate us to get access to more. When you're talking about something like Vault, this will be your Vault token. You get your initial Vault token, you use that to get access to other things. This is secure introduction. If you can protect this secret, you can protect any secret generally, but the idea is that if you can get one secret to your destination, you can use that to get other secrets. That's a secure introduction problem that we talk about a lot at HashiCorp. And that's basically the underpinning of this talk is we set out to say, okay, how can we solve secure introduction for a container workflow like Nomad needs, but in a general sense, like what are the things that we could do to make this problem easier and make it easier to solve? All right, so how do you protect secrets in the first place? So the first thing is you establish success criteria. And this is based on your organization's acceptable risk. Any given organization needs a security policy and needs associated success criteria. Nobody can devise this for you. It just doesn't happen. So the reasons you don't need to establish a security policy are none. You need to do this. There is no excuse. And to kind of back up what I said about the fact that it's very individual to your organization, I was talking with a retailer at some point who said, there are certain days of the year where we are very worried about our unsealed key management for Vault, because if Vault goes down and if we don't have a quorum of unsealed key holders around to unseal it, then we lose hundreds of millions of dollars, right? So, what should we do? Should we automate this? What should we do to minimize this? And I said, okay, well, let's talk about automation. If you want to automate, then you are increasing your risk that someone will get access to a single key instead of multiple keys, or compromise a single employee, or compromise some other piece of software that's storing that unsealed key. And then, excuse me, so you're increasing that risk, which means that your risk of a breach goes up. And so you have to basically say, okay, it's hundreds of millions of dollars over here, or what's the cost of a breach? How likely does that breach become if we change around our policy? And it's not necessarily a clear answer, because it might be that if there's a breach and credit card numbers get leaked, maybe they will end up being responsible for $60 million worth of damages. Maybe. Maybe compared to $200 million, maybe that's actually good. So there aren't always clear, obvious answers. And if you are an organization, you need to make sure that you are looking at what your needs are, your security policy, no one else's. So for this talk, we're going to talk about certain success criteria. And the security properties that must be implemented for this talk are: don't let them live forever, rotate or expire. We're going to go into some depth here. Distribute them securely, limit exposure if disclosed, have a break glass procedure, and detect unauthorized access. And we're going to go into what these mean. So first, rotation and expiration. So as lifetime increases, the chance that your secret will be exposed goes to infinity, right? So if your secret is around forever, the chance that it will be used forever will basically, or that it will be divulged at some point will go up. This actually happened to me recently. So I had some Skype account that I basically hadn't logged into in about 8 years. And I got a message from someone saying, hey, and it was some password. I didn't reuse the password anywhere, but it was probably, on the shorter side or something. It's before I was using a password management system. This long time ago. And someone said, hey, you're sending out messages to everyone on Skype. And I said, no, I'm not. And so I logged in. And in fact, I had sent messages to everyone on Skype. And so someone at some point had either brute forced, had gotten a dump of their database, had done something, and basically managed to either access my account through some means, or had managed to just, brute force the password and was posing as me. And, I didn't really think about it because I don't really use Skype, so I didn't rotate my password because I didn't even have it installed at that time. So the likelihood that there will be compromises, that things will actually be exposed, it always goes to infinity over time. And it's not always malicious. It could just be in caches and logs. They happen to leak out. Over time, someone could just crack it. There could be enough packets that they sniff, et cetera. Could even be debugging. Someone left some debugging code in and it just sends something out. Secrets should be rotated frequently and have lifetimes as short as possible. So there's actually a difference here between user passwords and machine passwords and how you want to think about this. So does anyone know what those four lines are? Shout it out. Yeah. Okay, so at least 3 people in this room know what that is. It's correct horse battery staple. So the whole point of that XKCD comic was basically the following. We have trained people through basically password policy to have basically passwords that are as short as possible and are actually very easy to guess, because I think the example that he used in that comic was Troubadour, where it was Troubadour and they substituted a 4 for one place, they substituted an @ for something else. And basically everyone's told, hey, you can't just use a word, you have to substitute some special characters in. So everyone substitutes the same special characters. So you don't actually have a much more secure password there. So the point was that we have trained users to actually do very insecure things that are actually very easy to brute force, rather than to use things that have actually a lot of entropy. So when you talk about user passwords, bad policies and requirements on frequent rotation means you are much more likely to actually get it written down. Or you're much more likely to get it where they have a bad password and they tack a 1 on the end, and then they tack a 2 on the end, and then they tack a 3 on the end, and so on. So less frequently and more used, more likely overseen. But for machines, it's actually a very different story, right? So machines, they don't care what that password is. They don't really care how often you change it. It's just data. It's just a string. So for machines, you really should rotate very rapidly or very often. Okay, distribution. This is the literal movement along the chain of trust to, from, people, machines. Very boring. However, there's one thing here, which is at a base level, whenever you're distributing a secret, it has to be covered. It can't be plain text, ever, ever, ever. So it could be encryption on the link. If you have a really good, have a TLS 1.2 link and you have perfect forward secrecy and all that, send it over that link, that's great. SSH, great, right? Wrapping, which we do in Vault, great. But don't ever send it in plain text. It will get, somewhere along the way, it'll get leaked out, it'll get intercepted, it just happens. All right, limit exposure. So this is the principle of least privilege. It basically says, look, you should not let people have more access than they need. And in Vault, we actually do this by having policies be denied by default. You have to actually explicitly give people access to get to things. So database credentials should only be specific tables, specific operations, sequences, joins, whatever. Login credentials should not be root, right? Give the minimal amount of sudo requirement necessary. It should never be giving someone like sudo to bash, right? So API credentials, minimal function set. Access detection. So things have a way of being leaky. Environment vars are a really common way to pass things into containers. They also are often logged, often by management systems, which just say, hey, this is probably really useful for you to know what network interfaces you're on, and here are the environment variables that you used, and so on and so forth. So they often are just logged all over the place. And they're also easily discoverable by operators. Anyone that can access Docker on a machine can access these. And operators that even can't access Docker but can access other utilities on the system in a privileged way can actually just look up environment variables. So basically, you have to actually know not just how to protect a secret, but whether to, sorry about that. Look at that. So it's important not just knowing if you've as protected a secret, but also knowing if someone has intercepted it. If someone that you have not intended to has accessed it. Does anyone here actually look at audit logs? Regularly, all the time? Yeah? Okay, all right. I gave a variation of this talk before, and there was one person that raised their hand, and my immediate response was, really? You do? It's great. It is great that you actually look at audit logs. Everyone should be doing that. No one does in practice, right? So out of this whole room, it was a couple people. Active detection, when possible, is much better. It's much better to actually be warned when something's going wrong than it is to say after the fact, okay, let me go look at my audit logs and see what happened and how I have to react. Break glass procedures. So you've been compromised. You know you've been compromised. Now what? Do you stop all further access? Do you perform forensics? Do you rotate all secrets? How do you actually rotate all the secrets? How do you figure out what they are? You need to figure this out during the planning process. You cannot figure it out afterwards. You just can't. Once you actually have a beast of a system all built, trying to shoehorn it in later when you haven't been thinking about this from the beginning is going to be impossible. Okay, so here's the good news. All this stuff that I've been talking about, all these things you have to worry about, all these things you have to do, you don't have to face this alone. There's been a recent explosion in free and open source software, secret management tools. There are things called Keywiz and Nox and Conjure and many more. There's also this thing called Vault. You might have heard of it. I have a little something to do with it. Every now and then I commit to it. Someone merges my PRs or something. Okay. Now, if you take away two things from this talk, out of everything I'm saying, make sure they are the following. Number one, write your own crypto. Number two, use it in a secret management tool. No. Everyone here knows don't write your own crypto, right? I've often heard it said that there are 5 people in the world that can properly implement a TLS stack, right? You don't write your own crypto. Use a secret management tool and don't roll your own. Okay, it's not that you're not smart people. Everyone here is very smart. You wouldn't ask me to develop a Java enterprise app, right? It's not in my wheelhouse. I don't know what I'm doing. If you aren't very sure of the things you need to think about, the way you need to think about things, and what you're doing, don't say to yourself, you know what? We only have very limited needs. We can just do, we can develop our own secret management tool. It can't be that hard. It is that hard. Okay. So if you're not focused on that problem, don't do it. Trust something else to do it for you. So When I talk about things going forward in this talk, I am going to talk about things that Vault can do in terms of secret management capabilities. We have a focus on providing security primitives, which has let us build up some really nice workflows. So not everything that I'm talking about can be done by other secret management tools. That said, using a secret management tool, if it's not Vault, is still better than writing down passwords into an encrypted notepad.txt. All right, so secret management tools. Nice things that they do. Number one, they're centralized. You often hear it told by many people that are very into microservices, which personally I actually am, that nothing should be centralized because you have single point of failures. When you're talking about secrets, and you're talking about exposure, and you're talking about the ways that things can get out, you want this. What you don't want is basically the equivalent of when someone in a movie wants money and they start digging under their mattress and they start looking in the couch cushions and they start like opening up random jars because they know that somewhere probably they stashed some coins, right? You don't want that with your secrets. You want to know where they are. You want to know who can get to them, when people have gotten to them, and you want to avoid secret sprawl. Sprawl is basically like, all right, I have some secrets that are stored over there. They may or may not have lifetimes. These people may or may not have access. Some other group has other secrets that are stored over there. They have various lifetimes. They have various access. I don't know what they are. When you don't have a centralized secret management system, it's impossible to actually have a decent enforced security policy. You can't do it. Now, sometimes there are companies that will have secret management tools per BU or per group or in different kind of environments, and that's totally fine. But they're still using that within kind of a prescribed way. Okay, so central management, this is things like setting policy. Generally you want to say, look, we have 3,000 employees in our company. Anyone that is marked as a developer should be able to get to these things. Anyone that is a salesperson should never, ever, ever get access to these secrets. It's very hard to actually control that if you don't have a centralized way to do policy. Auditing, so who's seen access to what when. You can set up auditing centrally in your secret management tool. Otherwise, you have to ensure that all the right things are audited and logged everywhere. So this is a good place to do it. Codified secure access mechanisms. Vault enforces TLS 1.2 by default. We keep up with the Go crypto stack with their recommended cipher suites. We do all these things to make sure that the communication that you have with Vault is safe. Doing that with disparate secret management systems or really just with disparate secrets all over the place is very hard. Maybe over here using TLS 1.2, and over there using an older distribution that defaulted to TLS 1.0, and suddenly you've opened yourself up to stuff. And finally, secret rotation, revocation, expiration. So having a codified policy where you can say, look, someone can get access to the secret, but I have administratively set that they have to rotate it every 5 minutes, every 30 minutes, every 30 days. It's hard to do this when you have secrets spread out everywhere, you have secret sprawl. And just as another point of kind of to hammer home the whole central thing, you put your money in banks, right? You put your money in banks not necessarily because you trust the banks, but because they're backed by the FDIC, let's say, and because they're just a centralized place and this is what they do and they are designed to protect your money. Same kind of thing. So secure management solutions often, at least Vault does, but many of them do, have an explicit focus on the secure introduction problem. Excuse me. So this slide seems a little weirdly formatted when exported. Sorry about that. But it's a core competency from the ground up. So we have the right primitives, we have the right tools, we have the right capabilities. If you have 100,000 containers, you can do things like add 100,000 LDAP users, add 100,000 Kerberos key tabs. You can do these things, but do you want to? Does this sound like a good idea? Probably not. That's a lot of management. So secret management tools are designed to provide these kinds of capabilities to scale up. And secret management tools love schedulers, right? Anyone working with tasks, especially containers at scale, uses scheduler. And by scale, I mean probably above a couple hundred nodes, many thousands of containers. You get to a point where you have to be using a scheduler. So Nomad, Mesos, Fleet, Swarm, Kubernetes, whatever. Schedulers are sources of truth. They know what's running. They know where it's running. They know what the IP addresses are. They have ways to inject things in. And they provide hooks. So schedulers and secret management tools can be a really good combination. So we're going back to this diagram, right, that I introduced at the beginning. And so just to kind of recap, we've talked about, how do we think, what are the basic definitions of security? What are the things we think about? And we talked about, okay, what are some of the criteria that we're going to put on a secure introduction solution if we want to get that first secret somewhere so that we can then use it to access other secrets? How do we, what are the things that we need to do? What are the kind of the checkboxes we need to tick? So I'm going to be a little hand-wavy, mainly for time reasons, about this first step. So this is doing secure introduction to a scheduler. And the reason is, if you do things like, let's say that you're using Vault, you're using EC2 instances, and you're using Nomad on EC2, we have an AWS EC2 backend. We designed it very carefully with some very security-minded firms. And it's a really good way to do secure intro. And it's just something that, it's not really a part of this talk, because this talk was talking about how we develop secure intro for especially containers, but other things where we don't have trusted third parties, right? So a trusted third party for AWS is Amazon. They sign metadata. We can use that. So I'm kind of going to be hand-wavy about this and assume that you can do secure introduction to your scheduler or your scheduler agent on a box. All right, so this is part of the traditional stuff, so like I was talking about, AWS EC2. So this is the part that's new, right? So we have something running on a box, but now we have a bunch of containers we want to start. We say, all right, we want to figure out this secure introduction problem. So here's what we looked at. Over time, we built into Vault a bunch of things. We said, look, we have Vault tokens that have unlimited or limited use counts, limited time to lives, possibly renewable, possibly not, a set of authorization policies, right, that explicitly say what someone can do. We have consistent IDs and audit logs, and we have token scope secure storage. This is something that's really cool that a lot of people, I think, don't realize is there. It's something called cubbyhole. And by default, every token has access to it. And this is secure storage that can only ever be read by a particular token. It's one of the few things in Vault that root tokens cannot do. They cannot read another token's cubbyhole. So my claim and kind of the foundation of what we built and what we worked on is, he says, taking a drink to draw out the tension, is that these privileges allows excellent secret coverage. So a really good way to get secrets from point A to point B along our chain of trust. So here's an example workflow. So we have a scheduler which has, it says, I want to start an app, and here's a security policy I want to give to the app. And it goes to the agent. The agent has a token that, let's say it's a periodic token. It doesn't have a use count, and it can just, renew every 8 hours forever. And it has a policy called create app tokens. So the scheduler agent goes to Vault and says, I'm going to use my policy, create app tokens. And I would like to create a token, and this is the policy I would like for it to have. And Vault does something where it says, OK, here's what you want. You want a token. You want it to be unlimited uses in 1 hour. Like, that's the policy that's set. And the policy that's attached to it is what's part of your job, which is the appdb RW policy, so appdb rewrite policy. And it says, OK, so I can put this in the cubbyhole. I can put the token ID in the cubbyhole of a different token that has a single use, has 30 seconds, it's non-renewable, and has a single policy. And that single policy lets it do one thing, which is read that one value out of that token's cubbyhole, the only thing it can do. So then the scheduler agent can say, all right, hey, container, here's the image you should start, and here's your outer token. It can be passed in an environment variable, let's say. I know I said not to do that, but we're going to talk about why we can. So here's the token, and it basically just shoves that entire piece of data over using the token ID that was wrapping on the outside. And so the container can say, all right, hey, Vault, please unwrap this for me, which is basically, I want to do a read on this one endpoint that is the only thing I can access with this token, and I would like to get what's inside out. And Vault says, OK, here you go. And when we do that, the outer token is expired. It had a single use. And now it can say, all right, I want to get my DB creds. I want to, here's some DB creds. I want to get S3 creds. Here's some S3 creds. I want to get TLS cert. Here's a cert. Whatever. It can use that token for whatever it is that it actually needs to do and whatever it's allowed to do. All right, so let's look at our previous list. I established success criteria for this secure introduction problem of getting like an initial secret to a container and doing it securely. Don't let them live forever. So the outer token expires, has a use limit. The only copy of the inner token value is in the cubbyhole of that outer token. Not even root tokens can read it. Never exposed. So they don't live forever. Check. Distribute them securely. So the inner token is covered the entire way. Check. Limit exposure if disclosed. Only specific policies are granted. The only thing the outer token can do is read what's inside. And the token that you're giving to the application has a security policy attached to it that is scoped for what it needs. Check. Have a break glass procedure. So we can lock down access to the security management tool. We can revoke that token if we need to. We can use the accessor. And audit logs ensure that we know the area of exposure. So because we have a consistent ID, for that token that we HMAC into the audit logs, we can say, okay, I can see everything that that token did, and I can start revoking things. Check. And detect unauthorized access. All right, can we do that? Well, it turns out we can because of the time limit and the use limit. So if the application reads the inner token and has success, great, perfect. If it reads storage but no inner token is found, we say, that's weird. It was a valid token, but I didn't find anything. That's probably some kind of bug in Vault. Hasn't happened yet, but hey, could happen. Invalid token, all right, here's where things get dicey. So we check the current time, we check the time that it was issued, and we check the TTL. We say, all right, are we within the TTL? If we are, that token should be valid. And the fact that it isn't valid very likely means that somebody else accessed it. Raise a red flag. Sorry, I'm going out of order, I think. Raise a red flag. We need to have someone look in the audit logs. This is a break glass procedure kind of time. If the token has expired, raise a yellow flag. We should probably make sure that nothing actually accessed that token. We should make sure that nothing, that it was never actually read. And if so, we can say, all right, we need to revoke anything that it, revoke that token, and so it'll revoke pieces that it had access to. Or see, like, which paths in our KV storage did it look up, right? Maybe we need to rotate those things. So we should probably investigate, we should at least investigate to find out why did this happen, because we don't want to see these yellow alerts all the time, right? So we want to say, what took so long? So, access detection, check. And sometimes this is the best you can do. Sometimes you have, if we have an SSH channel and we trust, all right, we can trust the user that's going in SSHing in, or we have a TLS connection, we can send things down that encrypted path. Sometimes when you're talking about things like environment variables, this is about the best you can do is actually figure out if the wrong person saw it. So this paradigm is actually so useful that in Vault in 0.6, we actually made it available for almost any Vault call, and we call it response wrapping. And I think they mentioned this in the keynote. And it turns out that this is actually, using this paradigm is the answer to a lot of things. Because getting something from point A to point B and making sure that nobody saw it, and making sure that you can detect if the wrong person saw it, turns out to be pretty important. So it's a mechanism that isn't container authentication specific, which is why we have it for basically all of the API. If you're using the CLI, it's just a wrap TTL parameter, which is the TTL you want. Or if you're using the HTTP API, it's a header value. So, as an example, a configuration management tool can drop a wrapped secret on an EC2 instance. So the configuration management tool can say, hey, generate me a token and have it wrapped. And the configuration management tool can say, okay, hey, EC2 instance, I'm going to SSH into you, because I have my private key is part of your authorized keys, so I can SSH in, and I'm just going to drop the wrap token there for the client to pick up. And there's deniability there, and that's a really nice thing, where you can basically say, the configuration management system can say, I can prove that I didn't actually access this token. That the only person that ever saw this token was either the intended recipient or someone that we need to try to investigate and find out where along this way did it happen. But the configuration management solution can actually say, I never saw this. And we know that it's true. Okay. And another nice thing that's built in here is we have these things in Vault called token accessors, which are basically references. And the references basically let you do two things. Look up. You can't look up the token ID, but you can look up the token properties that the accessor is associated with, and you can revoke a token. So if you have something like a Nomad, then it can get a wrap token, and it can store the accessor. And when the job is done, as soon as it's done, it can use that accessor to revoke the token and all of the leases associated with it. So you don't need to let those live any second longer than they absolutely have to. So that's revoking as soon as possible, it's expiration, it's all those good things. Integration. So, Nomad and Vault integration has been talked about. It was talked about in the keynote. Alex Dagger had a talk yesterday about it. And Nomad integration uses a variation of this scheme. But when we were looking at it, we weren't trying to solve specifically for Nomad. We were trying to solve a general secure introduction problem that could be used in many kind of paradigms, in many sorts of situations. So, this is something that we built. And like Nomad's not using anything special. It's using the full public API of Vault. So, some of the things that Nomad does is they use a user supplied token. They check it for access to make sure that the user requesting a job, requesting security policy, has those appropriate permissions. Another thing that could be done is the user can request a job, but it could be administratively configured in some other solution, administratively configured to say, hey, this type of job, these users can submit it, and it's associated with this policy, and it's just done in a different way. So Nomad does this. It does this in certain ways, but like this is something that can be done by any anything, really. And kind of as a follow-up to that, I actually think that this is a really good example of the way that HashiCorp thinks about things, the way that we follow the Unix philosophy. We try to do one thing, do it well, instead of do all in one. And in many cases, this actually works out to our benefit, because we say, look, we want to tackle this problem in a generic way, and we think about it in a generic way. We don't only think about it in terms of Nomad. And so as a result, any scheduler can implement what Nomad did. So I just think that it's a really nice way to kind of show the strength of the way that we generally think about how we build our software. All right, so wrap up. So don't ignore risk, minimize it, right? Risk is security. Managing risk is security. Your organization needs a security policy. You need to base it on your risk tolerance and where your risk vectors are. You need to figure out your circle of trust, your chains of trust, and then you need to decide, okay, now that we know who we can trust, and we know where we need to get things around, how can we protect it? And maybe it's through using Nomad and Vault. Maybe it's through using this kind of paradigm with some other system. Maybe if you're using Mesos and you're stuck on it, and you say, all right, we're just going to build this into Mesos. So use Vault or some other secret management tool. Don't go it alone. They're there to help. Hopefully you understand why, out of maybe anything you do in microservices, why it's still a good idea to have centralized secret management. And finally, orchestration tools, great facilitators of secure introduction. And this is not only things like a Kubernetes and a Mesos and a Nomad, but it's also even things like Puppet and Chef, right? Those are basically, if you're running on bare metal, those are orchestration tools. And they can do a lot of these same paradigms, and they are sources of truth, right? They know that, it's this machine is on this address, and it should have this public key that I can use to get into it. And so they know a lot about the state of your system and how it's set up. That's it.